In this video, I will consider one example on DFT. The IDFT x of k is given by x of n is equal to 1, 2, 3, 4. Determine IDFT of the following sequences. We are supposed to find the IDFT of these four sequences. So here x of n is given, which is 1, 2, 3, 4. It means that I can write x of 0 is equal to 1, x of 1 is 2, x of 2 is 3 and x of 3 is 4. We know that DFT of x of minus n is given by x of n minus k, that is time reversal property. It means that IDFT of x of n minus k is equal to x of minus n of n. Now let me take the first example. Therefore, IDFT of x of 4 minus k is equal to x of minus n of 4, because in this case n is equal to 4. So which is also equal to x of n minus n, that is 4 minus n. So simplifying this, I can get which is equal to, here for n equal to 0, we'll get x of 4. So x of 4 and x of 0 both are same. Therefore it is 1. Now for n equal to 1, here we'll get x of 3. So x of 3 value is 4. Then take n equal to 2. It will be 4 minus 2, that is x of 2. X of 2 value is 3. Then take n equal to 3, that is 4 minus 3 is 1. X of 1 value is 2. So the IDFT of x of 4 minus k is equal to 1432. So this is the answer. The IDFT of j power k x of k, that is j power k x of k. I will represent this j power k x of k as e power j pi by 2 into k x of k, because we know that e power j pi by 2 is nothing but cos pi by 2 plus j sin pi by 2. So cos pi by 2 is 0 and j sin pi by 2 is 1. Therefore it is j. Therefore e power j pi by 2 is nothing but j. So further I will represent this as e power minus j pi by 2 into minus 1 into k x of k, which is same as this one. So now therefore we know that DFT of any sequence, circular sequence x of n minus l, its DFT is given by e power minus j 2 pi by n into l, that is this l, into x of k. This is time shift property. It means that IDFT of e power minus j 2 pi by n into l x of k is nothing but x of n minus l. Therefore now I can write IDFT of e power minus j pi by 2 into minus 1 into k x of k is equal to x of n minus 1, that is nothing but n plus 1 of 4, because here n is equal to 4. So here x of n plus 1 is nothing but shifting x of n sequence towards left by 1 unit. Here x of n value is 1, 2, 3 and 4. Shifting this or circular shifting this sequence towards left by 1 position. It means this sample will appear here. Therefore this will be shifted here, this will be shifted here, and this will be shifted here, so that we'll get 2, 3, 4, and this one sequence will get at the end. So this is the IDFT of j power k x of k, that is 2, 3, 4, 1. Now let me consider the third case, that is real of x of k. We know that real of x of k can also be represented as x of k plus complex conjugate of x of k, that is x star of k whole divided by 2. Therefore now I can say IDFT of real of x of k is equal to, we know that IDFT of x of k is x of n, so this can also be represented as x of k by 2 plus x star of k by 2. So IDFT of x of k is x of n, 1 by 2 is a constant, I will write it as it is, x of k is x of n plus, here 1 by 2 I will write, the IDFT of x star of k is nothing but x star of 4 minus n, that is by complex conjugate property. So therefore I can write 1 by 2, x of n sequence given is 1, 2, 3 and 4 plus 1 by 2, x star of 4 minus n is, so if we take n equal to 0, x star of 4 is nothing but complex conjugate of x of 4. So here x of 4 is nothing but x of 0, that is x of 0 is 1 itself. Similarly, if we take n equal to 1, it will be x star of 3. So x star of 3 is nothing but 3. X star of 3 is nothing but x of 3, which is 4 here. If we take n equal to 2, it will be x star of 2. X star of 2 is nothing but x of 2, that is x of 2 value is 3. Then if we take n equal to 3, it will be x star of 1. So x star of 1 is x of 1. X of 1 value is 2. So simplifying this further, I can write 1 by 2 is 0.5, 2 by 2 is 1, 3 by 2 is 1.5, 4 by 2 is 2. This is one sequence, and another sequence is 0.5, 4 by 2 is 2, 1.5, and we have 1. Now we'll add these two sequences bit by bit. That is 0.5 plus 0.5 is 1, 1 plus 2 is 3, and here we have 1.5 and 1.5 is again 3. This is 2 and this is 1 is 3. So this is IDFT of RE of x of k, that is 1, 3, 3, 3. Here the fourth problem, that is IDFT of imaginary part of x of k. We know that imaginary of x of k can also be represented as x of k minus x star of k, that is complex conjugate of x of k whole divided by, it is j2. As we know, in real case it is divided by 2, here it will be divided by j2, which can also be represented as x of k by j2 minus x star of k by j2. So therefore now I can write IDFT of imaginary of x of k is equal to, we know that IDFT of x of k is nothing but x of n. So 1 over j2 x of n minus, we have 1 over j2 IDFT of x star of k is same, that is x star of 4 minus n, which is done in previous case. So 1 by j2, x of n value is 1, 2, 3 and 4 minus 1 over j2, x star of 4 minus n is nothing but 1432, that is 1432. So simplifying this I can write, so 1 upon j2 is nothing but minus j 0.5, 2 by j2 is nothing but minus j1, that is 1 upon j is equal to minus j, 2 by 2 is 1, 3 by 2 is 1.5, that is minus j 1.5, then we have minus j2, this is one sequence, minus here we have minus j 0.5, then we have minus j2, then minus j 1.5, then minus j1. So simplifying this, minus j, so here minus j 0.5 and plus j 0.5 will get cancelled, will get 0, minus j1 and plus j2, it gives j1, or we can simply write j comma minus j 1.5, and here it is plus j 1.5, it will be 0. Then we have minus j2 plus j1 is minus j or minus j1. So this is the IDFT of imaginary of x of k. Thank you for watching.